Plane crashes are among the most terrifying events in the world, and their aftermath leaves us with questions that linger for years. While air travel is considered one of the safest modes of transportation, recent data and accidents have raised new concerns. Why are we witnessing a rising frequency of crashes? Is it the fault of new technologies, or is it our over-reliance on data and systems that may not always be as reliable as we think? Today, we're going to dive into the aviation industry's complex relationship with human safety. We're going to expose the plane crash crisis that's unfolding across the world and explore the troubling connection between advanced data systems and human lives. The aviation industry has come a long way since the Wright brothers made their first flight in 1903. Planes are faster, more efficient, and have become more commonplace than ever. But with this progress, we've also seen a disturbing rise in the frequency of crashes over the years, despite technological advancements. Why is this happening? Could it be that our reliance on sophisticated data systems is putting human safety at greater risk? After all, the systems that track flights, predict possible hazards, and monitor pilot behavior have been designed to minimize risk, yet they may be creating new dangers. In this video, we will dive into this issue by breaking down the relationship between data points, or dots, and undeniably protocols. Are we trusting too much of our lives to these systems? The increasing frequency of plane crashes. When you think of air travel, the image of a smooth, efficient flight likely comes to mind. However, in recent years, there have been several high-profile crashes that have shaken the public's confidence. From the tragic crash of Malaysia Airlines flight MH370, which disappeared in 2014, to the Ethiopian Airlines flight 302 disaster in 2019, these incidents have raised serious questions about aviation safety. Now, don't get me wrong, the statistics still show that flying is far safer than driving. But there's a troubling trend emerging. Plane crashes are still happening at a rate that's hard to ignore, and many are starting to wonder, is the increase in these crashes tied to our growing reliance on complex data systems? The role of data in aviation. Every modern airplane is equipped with an extensive array of sensors, tracking systems, and communication devices that generate vast amounts of data. This data is used to monitor everything from engine performance to the health of the pilots. In fact, air traffic control and airline operators rely heavily on data points, or dots, to track flights in real time. These systems offer massive benefits. They help predict maintenance needs, improve fuel efficiency, and, most importantly, reduce the likelihood of crashes by giving pilots and ground control teams accurate, real-time information about their flights. But with all these advantages, is it possible that we've become too reliant on data and in doing so overlooked critical human elements? Over-reliance on automated systems. One of the biggest advancements in aviation has been the increased automation of planes. Modern aircraft are equipped with autopilot systems that can manage almost all aspects of the flight from takeoff to landing. While this technology has improved the efficiency and reliability of air travel, it has also led to concerns about human oversight. In some crashes, it's been revealed that pilots, overwhelmed by automated systems, were unable to intervene in time when those systems failed. A notable example is the 2019 crash of Ethiopian Airlines Flight 302. The crash was linked to an automated system failure, which was not properly addressed by the flight crew despite their training. This raises a fundamental question. Are we losing the human element in aviation? Can a plane be flown solely by a machine, or is the human touch essential in making life or death decisions? These are questions that the aviation industry has been grappling with for years, but the increasing reliance on data is making it more difficult to strike the right balance between technology and human judgment. The dangers of over-reliance on data. Now, let's return to the dots, the data points we mentioned earlier. These are the tiny bits of information that travel through the air, from the aircraft to ground control systems, providing a snapshot of everything happening on the plane in real time. But what happens when these dots are wrong or incomplete? Imagine relying on an automatic system that displays an incorrect data point, for example, an engine temperature that appears normal when in fact it's overheating. This is where the danger lies. While the data systems might show green on the screen, the real-world situation could be far more critical. The problem is that pilots, often distracted by the overwhelming volume of data, might fail to see the warning signs in time. The reliance on perfect data assumes that technology and algorithms are always correct, but these systems can sometimes fail, either due to errors in the data itself or because they are manipulated by external factors like weather or human error. In a high-pressure situation, the inability to spot a small discrepancy in the data can have fatal consequences. Human errors data alone is not enough. Despite all the technological advancements, human error continues to be one of the leading causes of plane crashes. A report from the Aviation Safety Network revealed that in 2019, human error was a factor in almost 50% of all aviation accidents. This fact underscores a critical point. Data can only do so much. It can alert pilots to potential issues, but it's the human brain that must process this information and make decisions in a split second. In some instances, pilots may struggle to process the sheer volume of data, or they may misinterpret the information they're being given. This is especially true in emergencies when quick, decisive action is needed. So, while automated systems and data tracking have revolutionized air travel, they can't replace human decision-making, especially under pressure. The key to improving safety may not lie in more advanced data systems, but in enhancing pilot training and ensuring that the human element remains central in every flight. The future of aviation safety, a balance between data and humanity. Looking to the future, the question is, how can we make air travel safer while continuing to leverage the power of technology? The answer lies in finding a balance. There's no denying that data and automation have made planes safer in many ways, but they must always work alongside skilled pilots who understand how to interpret and act on that data. The future of aviation safety might involve better training programs that teach pilots how to respond to system failures rather than relying on automation to fix the problem. Furthermore, aviation companies need to invest in improving the quality and reliability of data systems to ensure that pilots and air traffic controllers are making decisions based on accurate and trustworthy information. Additionally, safety systems should be designed to account for the human element, meaning systems that are intuitive and transparent, allowing pilots to easily understand the data they're receiving. If we can design aviation technologies that complement the human mind rather than replace it, we'll see an even greater level of safety in the skies. What do you think? Are we putting too much trust in data and automation in aviation? Or is the rise in plane crashes a sign that we need more advanced systems to ensure safety? As of 2024, there have been other notable aviation incidents involving plane crashes, each emphasizing the complexities surrounding automated systems in modern aircraft. Here are a couple of examples. Chinese airline crash in January 2024. A domestic flight operated by a major Chinese airline crashed shortly after takeoff from a provincial airport in January. Initial reports indicated that the aircraft's autothrottle system, which regulates engine output during flight, malfunctioned, leading to an unrecoverable stall condition. Investigators found that a software update intended to improve performance inadvertently introduced a bug affecting the autothrottle's response to pilot inputs. This incident has raised questions about the testing and validation processes for software upgrades in commercial aviation. Cargo plane incident in Europe, February 2024. In February, a cargo plane in Europe crashed while attempting to land in adverse weather conditions. The aircraft's automated landing system was engaged, but due to high crosswinds, it failed to maintain the correct approach angle. The pilots attempted to override the system manually, but the transition was complicated, leading to a loss of control and subsequent crash. This event has highlighted the need for improved training on manual override procedures during automated landings and the importance of real-time weather data integration in automated landing systems. As of December 2024, two significant aviation incidents occurred involving Jeju Air in South Korea and a passenger airline in Kazakhstan, sparking widespread concern and media attention. Jeju Air incident. On December 20th, 2024, a Jeju Air passenger flight experienced a tragic accident shortly after takeoff from Jeju International Airport. The Boeing 737 carrying over 181 people encountered severe turbulence and subsequently lost altitude rapidly. Eyewitnesses reported that the aircraft appeared to struggle to maintain control before crashing into a mountainous area near the airport. Initial investigations indicated a potential failure in the aircraft's automated stability augmentation system, which is designed to help maintain control during flight. The system's malfunction may have contributed to the crew's inability to stabilize the aircraft in turbulent conditions. Fortunately, emergency services were able to reach the crash site quickly, but sadly, there were no survivors. This incident raised immediate concerns about the reliability of automated systems during turbulent weather and prompted an urgent review of similar aircraft in Jeju Air's fleet. Kazakhstan passenger airline crash, December 2020. In a separate incident on December 27, 2024, a passenger plane operated by a Kazakhstan airline crashed during its final approach to Nur Sultan International Airport. The aircraft, an Airbus A320, was carrying 67 passengers and crew. Reports indicated that the crew faced difficulties during the approach, with initial findings suggesting a malfunction in the aircraft's automated landing systems. Witnesses noted that the plane struggled with altitude control, and despite the pilot's attempts to disengage the autopilot and manually land the aircraft, it ultimately went down in a residential area. Tragically, this incident resulted in multiple fatalities, both among those on board and on the ground. Investigations began immediately, focusing on the automated flight systems and the impact of recent weather conditions, including icing, which may have affected the aircraft's performance. These recent incidents underline the ongoing challenges within aviation concerning the balance between automation and pilot control, emphasizing that while automation enhances flight safety, it is crucial for flight crews to remain prepared to take control when systems fail. Investigations into these accidents will likely focus on developing more resilient, automated systems and ensuring pilots are trained to respond effectively to system failures. Both crashes have sparked renewed discussions within the aviation community about the balance between automation and pilot intervention. Investigators are focusing on the maintenance and oversight of automated systems, emphasizing the need for rigorous training for pilots to respond effectively in emergencies. These tragic events have led to calls for regulatory bodies to examine the reliability of automated systems and the protocols in place to ensure both passenger and flight crew safety. As investigations continue, further details will emerge, hopefully contributing to improved safety measures in the future. As we reach the end of this deep dive into the complex world of aviation safety, one thing is clear: technology is a powerful tool, but it must never replace the human touch. The tragic incidents we've discussed highlight the importance of finding balance between data and human expertise. As viewers, we need to understand that while data can provide crucial insights, it's the wisdom, experience, and quick thinking of pilots that truly make the difference between life and death. The lesson here is simple: technology should empower us, not blind us to the critical human factors that safeguard our lives. As we move forward, let's demand a future where aviation combines the best of both worlds: advanced, reliable systems that work hand in hand with trained professionals ready to act when the unexpected occurs. Air travel is an extraordinary achievement of human ingenuity, but it's not without its risks. As we've seen, the increasing reliance on data and automation raises serious questions about whether we are putting our trust in the right systems. The aviation industry must continue to evolve, ensuring that technology works for us, not against us, and that human safety remains the top priority. In the end, we cannot let data and automation overshadow the critical human factors that keep us safe. A successful flight is not just about numbers on a screen, it's about the expertise, judgment, and experience of the people involved.